Now that we have jointed the saw and gotten the teeth all the same height, then the next step in the process is fitting up the rakers. Normally when I do this, I'll drop the saw a little bit to give the saw more support, because when you're filing across a piece of basically thick sheet metal like this, if you don't have as much support as possible behind your teeth, it'll screech and make all kinds of noises and wear out your files faster. And normally, and this is personal preference, but what I do when I'm filing is that I wear a glove on my right hand, and it's kind of a peculiar glove. You'll see it's got just an extra flap over here, over this finger, because when I'm filing the cutter teeth, every once in a while my hand will actually hit the back of the tooth, and if I don't have a glove on here, it peels the hide off my knuckle. And I also wear a thumb glove like this, because when I'm holding the file, I use a lot of pressure on the file, especially when I'm using the file for the rakers. You've got an edge on there that can bruise your thumb pretty badly. Fitting up the rakers is a fairly involved process. These particular rakers here are what we call straight rakers. This is a saw which is essentially new. It hasn't had any filing before, or if it has, very little. And the straight raker, the line of the front of it just comes right straight up on a continuous line. And this is called a straight raker. A swedged raker is where you shape the tip of the raker in a curve, which helps lift the shaving up and make the saw run a lot more efficiently. And the process for doing that is you actually shape the tip of this into so it's a wedge of metal about 20 or 30 degrees wide, somewhere in that range. And that makes it thin enough so you can hit it with a hammer and bend it over. That bending process is called swedging. Crosscuts are made by a punching process, and that means that between the sound metal of the saw and the blank that's being punched out, you'll often have very rough metal on the faces of your rakers. And it's a good idea to clean that up down to shiny parent metal before you start the filing process, because one, it's rough and it generates more friction for the shaving coming off. And also, if you have rough fractured metal on the outside face of the raker tip, I think there's a larger chance of actually breaking a raker tip when you swedge it. So you want to have good, clean, smooth metal on each face of your raker. To clean that up, to dress it, I again just use my slim taper file, and it's best to do that the first time you ever have a saw when you have straight rakers, because with a straight raker saw like this, you don't have to worry about damaging the swedge as you're doing the filing, because the file just conforms to the essentially straight part of the raker a lot better than if you have a swedge on there. If you have a swedge on there, which is a bend or a hook, then it's really easy with the corner of your file to put a nick in the bottom side of that swedge, and then when you further swedge it, there's a good chance of breaking it off. So the cleaning process is pretty straightforward. I just put the file right on the face of the raker like this and file across the tooth, trying to keep the file as perpendicular as I can to the body of the saw. And clean all the rust and cruddy metal off of there down to good clean parent material. Now, when I'm doing that, it's important to make sure that you keep the file not only moving forward where it's cutting, but also keep it moving down the tooth, because you'll see that the silhouette of this has a slight curve to it, And if you don't move the file, that is, if you just run the file straight across, you'll get notches and flat spots on it. So you have to make sure that you keep that file moving down the tooth so that you get a clean curve in that, rather than one that has various steps in it. A file really only cuts in one direction. The teeth are just like the teeth of a saw, and so they're designed to cut just in the push direction. If you put much pressure on it in the backstroke, you'll damage the teeth and take a lot of the life out of the file. It's important to put pressure on it only on a push stroke. If you want, you can leave a very light pressure on it on the backstroke, but don't put any appreciable amount of pressure on it. Okay, normally when I file a saw for any of these actions, I start off at the left-hand end of the saw and work my way over to the right. So when I'm dressing the raker tips, I'll start off down here. And I'll dress the inside face of each raker. When I'm doing any one particular operation, I do that operation to the whole saw and then turn the saw around and do it to the other side. So on this particular operation, what I've done is dress the face of all my rakers, and then next what I would do would be to take it out of the vise, turn it around, and then do the other side. Okay, once I've dressed up the outside of the raker like this, now the next step is to file the raker gullet itself to depth and then shape the raker tip so I can then swedge it. As I mentioned before, I use an 8-inch slim taper file to do this. When I'm filing, especially on a raker that I know has a lot of metal that I have to take off, I actually drop the handle of the file just a little bit so that it doesn't vibrate and make such shrieking noises. If I file straight across this, you get a noise like that, whereas if I just drop the handle a little bit, it makes a huge difference. Now, there's a great difference in filing a straight raker compared to filing a raker that already has a swedge on it, and we'll talk about that in depth when we get there, when we actually swedge a raker. Okay, my intent when I'm filing the raker gullet to depth is do my best to keep the bottom of the raker gullet in the center of the body of the raker. If you get it over to one side, it'll change the angle on that wedge of metal depending on which raker tip you're working on. Now, how do we actually treat the raker tip? What are we actually trying to accomplish right at that edge? Often after you've jointed it, you'll have a little bit of a bright spot or a flat, which is created by the jointer file hitting that raker tip. And when you're pointing up a raker that has had that happen, you want to file up your tip to where you got a flat spot here on the tip. You want to file it up to where that flat spot just almost disappears. Essentially, you bring it up to, for all intents and purposes, a knife edge. But you don't want to take it past that, because if you take it past that, you actually shorten the raker tip. Okay, now the question arises, how deep do you actually take that raker gullet? The answer is, it depends. What it depends on is what you're ultimately shooting for is to create a wedge of metal on the tip of this raker that you can swedge. And to do that, you have to be able to get your file deep enough into the raker gullet that is, for a straight raker saw, the straight line from the bottom of the raker gullet to the tip will result in an angle, and at the tip of somewhere between 20 and 30 degrees. So what that means is that if you have a crosscut that has pretty wide rakers, you have to go deeper with your raker gullet than you do with a saw that has pretty narrow rakers. Because we're dealing with angles here rather than depth. Your depth is determined by what angles you actually want to achieve. So you can't really say how deep you want to go. The question really is, how do you form the angle at the tip that you want? And the angle of the tip that you want is determined by how deep you've taken your file. If you take your file really deep, then draw a straight line from the gullet up to the tip, you'll end up with a very skinny tooth, which will bend easily, but it'll also be very weak, so that if you hit a knot, there's a good chance of either bending or breaking that raker tip off. So it's a kind of a complex relationship that ultimately your depth is determined by what angle you're looking for here at the raker tip itself. Okay, I've got the raker about to the depth that I want to, and I still have the tip of it still considerably thicker than will effectively swedge. So I'll rotate the file just a little bit and start working and taking more metal off of the tip of that to where I end up with a good thin, uniformly decreasing in thickness tip. You can't just run your file from the gullet out to the tip. You have to roll the file to actually follow the curve of that underlying swedge, which complicates things even more. But on a saw like this with a straight raker, it's fairly straightforward to begin with. Now, a lot of saws that you will be filing, previous filer has already put a swedge onto. In essence, because of the curve of the swedge, you'll end up nearly cutting the swedge off, or at least what you will do is you'll end up with a very thin, weak raker tip. So what I do, I'll file it down just like I do a straight raker. Once I've got my raker depth down to where I want it, instead of taking the file up on a straight line from the bottom of the raker gullet to the raker tip, because of the swedge in there, you have to actually roll the file slightly over the raker tip itself that's swedged. Otherwise, you'll end up cutting the raker tip off or making it very thin. So what I do normally is file the raker gullet a little bit deeper, and then I'll just do this with my fingers or my thumb off the end of there for illustration. I bring the file up. You can see I'm actually rolling it over the tip of that raker to follow the curve of the underlying swedge. I'll file all of the rakers down to depth for the left-hand raker tips and shape up the raker tips and get clear down to the end of the saw, and then I'll do the swedging and final fitting up of the left-hand raker tip, and then to do the right-hand raker tip, I'll flip the saw around. And there's a couple advantages to this. One is that that assures that each raker tip is symmetric, because if I try to file and shape this raker tip, my whole body stance and everything is different than when I'm filing this raker tip, and so there's a good chance that that the right-hand raker tip would have a little bit different geometry to it. So by flipping the saw, I'm assured that each raker tip has the same geometry to it.